Today we're talking to Brian Hobby. He's the technical lead in IT and engineering at Griffith University. Good morning, Brian.
Yeah, good morning, Nick.
We're also bringing on Scott Smith. Scott is the industry principal for facilities at OSIsoft. Good morning, Scott.
Good morning, Nick. Good morning, Brian.
Hey, well, why don't we start by Brian? Can you please describe Griffith University and tell us what your role is there?
All right, Griffith University is based in southeast Queensland in Australia. So we have 5 campuses spread across the southeast corner. So we've got in the order of 50,000 students, about 4,000 staff. We operate out of about 130 plus buildings across the 5 campuses. And if you're thinking in a classic automation sense, my role is probably akin to what you call a systems integration engineer. So my background's electrical engineering, and I've come from both a defence, so a Royal New Zealand Navy weapons electrical engineering background, plus 17 years in Rio Tinto from a project engineering, design, install, commission, comms and coding perspective. So I sort of, if you like, am in charge of the interconnectedness of all things inside the engineering department. So IT, comms, protocols, historian. If it's an edge case and things need to talk to each other, that's where I sit.
Well, you mentioned it perfectly, the interconnectedness of everything. And to me, and what we're talking about, a lot of that's around data management, and data is a journey, right? And so I'd really like to understand where Griffith University started as their part of their journey, and where do you plan on going with that journey?
So it's a few years ago now, it goes back to about 2015, late 2014. The initial remit was looking at managing energy and understanding the baseline of the university's energy, and there was money allocated to do energy metering. And as with most of these projects that come up and start, they got some quotes from a few consultants, and we could, for the money available, probably get 2 of all of the buildings done if you went down the standard buy off the shelf and get a system. So we went back to the drawing board and had to think about it. So we looked at it very, very hard. It's a case of getting the low-hanging fruit and then thinking about how do we get to everything that we want to get. So the initial aim was to have an electrical meter for every building that gave us a view of each building across the entire university. So we could say, okay, how does this building perform from an electrical energy perspective? So that was the initial remit, and we got to that point in about February of 2016 that we had every single building with communication coming back to the OSIsoft historian. And then we've been quietly filling in the gaps and trying to build connectivity to our building management solution, and also looking at things like occupancy, so how many people are using space, and also further pushing out with the money that was still in the budget to look at things like utilities. So we've gone out and developed a solution to bring in the water pressure, temperature and flow for each of the 5 campuses at the utility interconnection point, so that we can understand what our water usage is and start doing things like looking at leak detection for water and some of the other things that you can only do if you're looking at the data in a near real-time perspective. You know, a 3-monthly bill tells you that we've just spent an extra $500,000 on water. If you look at it and go, oh, we're using an extra 3 cubes in that building every day, that can be a very, very powerful visualization of the process and allow you to get on things early.
Absolutely. Brian, one of the things you mentioned is occupancy around understanding space utilization. And I know a lot of universities struggle because we don't badge in, we don't badge out. It's an open campus for students. So how did you guys really figure out to understand occupancy around your space utilization?
Well, initially we were looking at the high use spaces, so things like big lecture theatres. because again, from an energy perspective, they're the ones that eat the energy. So we were initially trying to look at, could we use things like a fisheye Ethernet camera looking down, into a space and look at an empty theatre versus a full theatre and count some pixels and go, does that tell us it's 10%, 50%? How full is it? Because if you've only got 200 people in a 1,000-seat theatre, then you're doing a lot of cooling of space for no reason when you potentially could put that course in a smaller space. So we trialled that and we had some success, but then, as always, miniaturization and costs of devices came down. So we've gone to what comes out of the retail shopping centre space. We've shifted to a Brickstream camera, which does people counting through doorways. So effectively, you put a power over Ethernet camera into a doorway, and every 5 minutes it basically does a visual check and goes how many blobs have gone in and out. And the problem with that is, of course, if you've got 4 doors, you've got to put 4 up. But the being power over Ethernet, data comms and cameras in this space for these sorts of things are a lot cheaper than they used to be. So it becomes something that will give you near real-time visibility of the utilization of that. We're up to several hundred spaces that we monitor. Generally, we're looking at things like lecture theatres, seminar rooms, in some instances laboratories, stuff that's bookable, that we want to have questions like, it was booked, was it used? And it also starts to give you profiles of, people go, oh, we need more of the space. And we go, well, you're not using the stuff you've got because we're not seeing people in it. So, it helps very much to look at, what's used, when is it used, and you can start asking questions when people go, well, we can't get one of these. And so, well, have you considered Friday afternoon? It's never used on a Friday afternoon. I'm sure everyone's decided we're going to the pub on Friday afternoon and nobody wants to actually either learn or teach then. So, there's a lot of space then.
So no, yes, it's a very...
Yeah,
sorry, go ahead.
Yeah, so space is it has grown somewhat because historically space utilization was done by employing undergrads to go around, with a clicker and stand at a door once every 6 months, and then you'd sort of, hope that was close to right, and you would make multi-million-dollar build decisions based on that. So it has assisted. I'll just share up a screen here. I've got one of. This is a library visitor dashboard. So this is literally taking the Pi data from the cameras in the background and aggregating it for each of the libraries across the university to give us visitor numbers. Today's visitors, October. So all of this data is coming out of the historian in the back end. And again, we can see that the yearly trends over time. We can see COVID impacting us. So, this basically, the Brickstream cameras deliver a count every 5 minutes, and then we aggregate this inside OSIsoft and deliver this up using the AF SDK and a web app in the background. So, this is one of the applications, and again, this is just for the library, so we've got a lot of cameras.
Nice. You actually touched on a key point there when you showed those trend lines of the impact of COVID. You're one of those organizations that are significantly impacted by COVID. And I'm kind of curious if you've been able to use the data either to help measure the impact COVID has had on your university, or if you've been able to use the data in how you respond to the challenges that COVID has put upon your university.
So we've got a what's the right term? Due to historical accident, we have a vast array of building ages. So from an air handling and a plant perspective, we're somewhat limited in most of our building stock into what we can actually measure. So they're fairly simple. There's a room sensor for temp, and in most instances, that's about it. And we're then dealing with potentially, if we're lucky, we might have a supply air temp sensor. So we're dealing with reasonably simple air handling units. So we don't have a lot of things we can do from a changes perspective. But what COVID has let us do is because the campuses were effectively closed down, you can't turn buildings off. But what it's allowed us to do is look at, okay, because we've got a meter on every single building, we can go, okay, the whole campus is supposed to be shut down. Why is that building still using 3/4 of the energy that it was using in the same period last year? Because we've got data for every building going back to 2016. So we can look at long run annual data and go, okay, this year, last year, year before, what was it doing? Okay, it hasn't changed even though there's nobody in it. So it's allowed us to go and look at things like the BMS controls and go, okay, why is this room on 24/7? It's exposed a lot of things that we've turned up, like chilled water pumps that's code has never been checked and was not actually right, and they were running 24/7 and not running in response to things like cooling demand for the building. So if we, I've got a Power BI that pulls out of an intermediate SQL database. So I push Pi data into SQL for use by Tableau and also Power BI if we wish to use it from an analytics perspective. So that goes up to some of our dashboards. So I'll just share up this Power BI chart, which gives us a bit of a view of the whole university. Okay, so this allows me to select by year, by building, by campus. So you can see the yellow chart is the impact of our energy use from COVID this year. So you can see we've been making gradual improvements over time in most months over the previous years from an energy perspective. But there is a significant drop through March, April, May, June. Okay, so again, this is the impact of the buildings and the campuses being closed down. And us as an engineering team, basically flat stick looking at, okay, why when the campus was shut down did this building not turn off, and going around fine-tuning, basically putting things in holiday mode, making sure there's the right management so we don't have mold issues. Looking at all those things, how do you minimize the energy use in the building without compromising the quality of air in the building, and also making it ready for people to come back into the building and have the building not be stuffy and moldy and all the rest of it. So you can see this large impact. So this is us being very proactive, going out there and using the detailed energy numbers that we've got accumulated over, as you can see, 4 years, and going, okay, why has this one not changed? And it's allowed us to dig in depth into a lot of the building management stuff. We've been quite busy, and going, okay, how do we improve this?
Yeah. So, Brian, from a maintenance point of view, what would you say the impact has been of all this?
Well, one of the benefits initially of grabbing energy is you can see what you're using where. So it's a journey, and as you both know that. The first thing is you measure energy and you go, what else can we measure? So we started looking at the building management system. So we have predominantly Schneider, but we have 3 generations of Schneider equipment. So we have iNet controllers, we have Xenta controllers, and we have the new automation servers, structureware based. So we had 9 different head ends, 3 for each of the technologies. We are now down to just structureware. The latest revision of structureware version 3 allows us to, if you like, embed the Xenta and the iNet into one software interface. And that software interface has a very nice web API which we've built to allow us to pull BMS data direct from that system into Pi. So we've got a little bit of bespoke stuff going on in that space from a maintenance perspective. So it's allowing us to get into things like air handling units and other stuff from a maintenance perspective. We're not at a point yet where we can go condition-based maintenance, but we'll just drop through a few slides and have a look at some of the things that flow out of the ability to bring in BMS. We've also brought in as much as we can from a chiller perspective, so we can view what's going on with those from a water temperature perspective. Because again, one of the key energy users in a big plant like this is things like chillers. I mean, Nathan Campus, you see down here, Gold Coast is our big draw at the moment. Is this one shared up? So
Yep.
This is the instantaneous power across all 5 campuses, including combined. So midsummer with full chiller load, we will touch between 10 and 12 megawatts combined across the 5 campuses. So it's a significant load, and a big chunk of that, for example, Nathan will pull between 4 and 5 megawatts by itself. Up to a meg of that can be chiller. So yeah, making cold water in Brisbane for air conditioning is a key function of what facilities does. So again, yeah, this in summer you will see a huge peak at the beginning of the day as all of the chillers launch to try and get the buildings in control. So I've fired a few screens up here, so we'll have a click across and see what I've got. So again, monitoring. Okay, I have a significant number of bits of Modbus infrastructure out there. All of our electrical meters are Modbus. Okay, so again, Modbus, it's out of the box, it's serial. If you're thinking about low-hanging fruit, if you're lucky, the majority of your metering out there is probably already Modbus capable. For a few $100s, you can get a Modbus IP to serial gateway and potentially a power over Ethernet adapter, and drop it next to the meter and start bringing that data in. So we bring in these units. I'm at somewhere between 400 and 500 electrical meters across the university. That's what's coming in through this Modbus interface feed. So this is my condition-based check every morning. Are all of my data gathering up? Okay. Is everything across my entire university online? This is built out of templates in the back end. So I built this once, and I have every single IP device that's providing me data across the entire university, one dashboard. Okay, so we bring in things like reverse osmosis water plant as well. Is it online? Is it talking to me? Okay, so again, simple checks, condition-based, red-green dashboards. If this goes red, this device is offline. I need to talk to my IT department and get things moving. Looking at remote monitoring for utilities, incoming water pressures across the campuses. So again, if you're thinking about utilities and fire management, one of the key things that you need is the right pressure at the building to supply your firefighting water. So that is contingent on having the right pressure coming over the fence so that your boost pumps actually deliver what you need at the top of the building. So pressure from a regulatory perspective and a reporting perspective for us is actually quite critical. So again, we've got near real-time pressure data coming in over the fence for every campus. Again, looking at management. So this is a water meter that looks at the chill water ring main at our main campus. So you can see occasionally we're seeing a little bit of water going into that ring main. If that starts to ramp really, really fast, we'd start looking for leaks in air handling units. Start walking around the campus and looking for the green water running down a drain somewhere that says, we're pumping lots of water into the ring main. Now, you expect a little bit of top up here and there. There's going to be the odd leak. But, again, simple checks. And again, trying to look at what are the right levels around this from a condition-based maintenance. So this will then email the hydraulics engineer that says, and the mech guys and say, hey, you've got a chill water problem, go looking. So starting to look at that part of maintenance now. Now we've got some measures that we're comfortable are delivering what we expect. N45, chiller. So this is our chiller compound. So we can see the field pressure, the supply and return pressures for our chiller plant. We can see the chiller stepping up as we add chillers, as we load up in the chiller house over time. So we can actually see how it's behaving over time. We can look at the external temperature that's coming in as well. So here we're bringing in data from the building management solution. So that's the load stages. We're coming in from the weather station on another building. We've got pressure sensors in the field on the ring main. Our main chiller plant in Nathan is a primary tertiary, which is a very, very odd configuration. The chiller pumps actually move all the field water, so it's very, very sensitive to pressure on supply and return to make sure we get water out to the buildings. So what else have we got? So again, chiller dashboard. Okay, what are our splits? What do we look like over time? So again, one place we can look at specific campuses. So again, this is using AF templates in the back end. We just pick a part of the tree and we can hone in on exactly what's going on. So again, N79, This building has its own chillers, so we see it turn off and drift overnight, and then we get down to a good split during the day. Main campus load never goes away. So again, this is water flow. So thinking about what can this show us. So down in this area here, we see a spike over days. You don't normally see something go up and sit. This is where we went back to campus. This chunk here, we sent our TA out into the field to go looking, because this just came up and sat for multiple days. Turns out when we went back to campus, some of the toilet cisterns kept running. So we had to get the plumbers in and sort out some of the seals and the seats of the toilet cisterns. And once we did, back down to what we'd normally see overnight. So again, this, if it had been left go, would be thousands of litres of water on our bill on the next 3 monthly. So again, I'm in the process of working with the hydraulics engineer to look at what are the right measures. How do we get a value out of this long-term data that can tell us when we need to look at this, so that the data informs us from a maintenance perspective. So again, starting to go down that hole of condition-based maintenance. But again, noisy data like water flows over time, when you've got occupancy of buildings and things, it gets interesting. So I'm going to break out some of my statistics and start looking at the statistical run chart type approaches to this, and maybe throw some standard deviations and various other things around it. Might need to talk to you, Steve. So putting stuff up out into the field. So again, this is something that we're doing something of as well, is interfacing with the academic side of the university and the teaching side of the university. One of our buildings is the Ecocenter N68. So it's a combination of the local schools teaching as well as the university. So this sits on a very large screen in the Ecocenter, so that they can show all the school kids that come in how the building works. So they've got a whole bunch of solar on the roof, so we can see the generation happening. They can see what the building's consuming at this point, and we can see the building exporting energy out into the local grid, so they can see what happens. We've also got 2 EV chargers down there. So the blue line is when someone's pulled in with their electric vehicle and charged up. So this allows a really nice visualization for the students down in the Ecocenter to see what's going on. And again, we've just started working with the academics to expose data as well for them to be using. They've used it in the teaching side occasionally, and there's been some papers published out of the data that comes out of the Sir Samuel Griffith Centre, so yes, we have contributed to the academic side as well in a couple of areas. So again, it's not just maintenance. A lot of the data we're collecting is being used both teaching, helping the academic side, and again, we're just right on that edge of starting to be able to do some very good, I'm expecting, condition-based monitoring. So again, N78, interesting building. Okay, it has a lot of meters in it. Everything on this screen is an electrical meter. This is what comes when you build to Green Star. So 2 main arrays are out at the moment for maintenance. But again, you can very, very quickly see what's going on in the building. Who's eating the energy? Is it the lights? Is it the mechanical? Is it the chiller? So again, this was originally built in Process Book. So this gives us a view of the entire building and what's going on with it. This is where you get to that confluence. So this is N78 again. This is the big lecture theatre. So we're talking about space utilisation. So we can see up here the cameras. Okay, we can see the cameras of people going in and out of the building. So we can see the building management systems, motion detector going off alongside the people entering and exiting. So this is a week. We can see the chilled water valves out of the system responding to do the aircon. We can see our temperature sensors. We can see the humidities changing inside the room. We can see the fan VSDs responding to the load in the actual lecture theatre. We can also down here see the power and the total building load thrown in next to it. So we've got a combination of our occupancy details. We've got all of our BMS data that's coming across from the Schneider BMS system. And we've got our energy data for power and mechanical power just on that floor only. So we're just looking at the mech load for that floor. So as the fans ramp, we can see the energy respond. So again, when you start getting to the ability to put all of the data side by side in one near real-time solution, you can start to do some quite deep analysis of, are you using the correct energy for this application? It's not so much minimization, but are we using the right energy to deliver the right outcome? So
Wow.
again, this is one of those powerful visualizations of, we can see multiple different data flows into our system and look at them side by side. And that's what the historian does really well for us. Or you can look at it like this. Okay, so this is N78. So this is back from November last year when we had most of the things working. Unfortunately, the battery banks in here had a thermal incident in January and are no longer, and we're looking at what we put in instead of them. But again, N78 is a bit of a special building. We've got about 300 kilowatts of solar total. We did have a megawatt hour of battery storage. We have hydrogen fuel cells, and we have 120 kilos of hydrogen storage plus an electrolyzer. So effectively, it's a test case of what might be possible for a remote area system. So and I'm expecting that to over the next year or so, we'll get to a point where we have all the pieces of the puzzle back up and working again. But this is the sort of visualization that you can do of a building inside PyVision, and put the data up and make it simple for people to understand what's going on from an energy and a building management perspective. We're talking about digging into stuff. So N78, if you think about how you build your AF structure and your categories and your templating, you can do things like this. So this is every building at the university. This comes straight out of the AF structure. This is the building meter itself. This is all the sub-meters in the building. So in one view, we can start to see everything that's going on in the building. If our building's high in load, okay, we can dive in if we have sub-metering and go, okay, who is eating our energy? So you can dive in very quickly and go, oh, lights, on level 4. It's interesting, but it's only 1.2 kilowatts. So again, this allows us to jump across building to building quite quickly. Okay, any sub-meters. So again, a lot of our buildings, we only have 1 meter. Okay, so again, it's as and where it's available. So again, we're talking about low-hanging fruit before. Our first priority was get a meter on every building. So we are still in that condition for a lot of our buildings. Again, N79, our new building. So again, interesting visualization. So this is live now. So how much of the building load is making cold water? A significant amount of it. So again, a nice simple visualization in PyVision that you can do. Other things you can do. Let's look at about the last 3 months and give ourselves a dashboard. So I've got a whole bunch of analyses in the background doing some calcs for me so that I can make something that looks like a bar chart inside PyVision. One of these days we're going to have a bar chart in PyVision, and I will be very happy. So this tells us, okay, last year we used more energy than this year. So it's a very, very simple visualization. How are we doing? Green, we're using less. Orange, okay, not so good, about the same. Red, yeah, we've eaten more this year than we did last year. So again, these are all the big energy buildings, the ones over 75 megawatt hours in a 30-day period. So these are the big ones. Okay, so we can just go through the dashboard and go, okay, who's better, who's worse? What does it look like? Where do we put our effort so that we can go, all right, this one we need to look at because it's had a massive jump compared to last year. So again, simple visualizations. I'm a great proponent of simple visualizations. And again, once we get a handle on this, we potentially should be able to automate this from either an event frame or a notification perspective, and then feed it out. EV chargers, been playing with event frames to look at trying to get EV charging events out. Again, we're looking at potentially greening our fleet in the future. How many people are coming in and charging now? The answer is actually quite a lot. Okay, we're seeing quite a few EV charging incidents, which says that there's a bunch of folks out there with electric vehicles. And again, yeah, we can look at this in an event frame perspective and see how long, how much. We've got some people out there with some very good onboard chargers getting up to 17 kilowatts for short periods of time. Most people are at the 11 kilowatt. So that's probably most of our Teslas out there, able to do 11 kilowatts of charging on board. So from a maintenance perspective, there's a lot of things you can get out, potentially, well, especially when you get back to these sorts of views. Again, we're on the journey. So it's always a journey. Where we'd like to get to is this sort of data for every air handler across the entire university. But again, that's limited by funds, resources, and some of the very, very, very old serial comms in the original Schneider iNet controllers. There's only so much data you can pull through a serial link when you're also doing control over it. So.
Okay, great. Now, I know in a lot of projects, and we hear this all the time from customers, they get new understandings of things that they didn't really intend to learn. Were there any things like that you found in, that you weren't really shooting for, but now you've got some new understanding of how things work?
Well, if we go back to chillers, and we specifically go back to Nathan and this chiller house, we're about to replace the N45 chiller house. So we have, as I said, nearly 5 years of data for this chiller house. So a classic chiller house, you put in one low load chiller and multiple larger chillers because that's accepted knowledge. That's just what you do. So our engineering team analysed all of our data and looked at the COPs for our chillers. And the new chiller house is going to have 2 small chillers and 2 large chillers initially, because we're in Brisbane. We only have high load for about a quarter of the year over summer. And the rest of the year, because we see this very, very flat demand for a lot of the rest of the year, if we only had one low load chiller and it went down, we would have to short cycle one of the big chillers. So, out to our consultants, we went, no, we want 2 small chillers, 2 large chillers. So this is a direct result of analysing the real data from our real systems over a long seasonal period of time and going, what is the actual energy consumption of this plant? What do we actually need to deliver to make our campus work? So
Okay.
that's interesting. The chiller numbers have literally directly impacted what chillers we get in the new chiller house.
Okay, great. Well, we've got about about 10 more minutes in our interview. Scott, you had some questions just in general about cybersecurity, resources common to universities. What was that about?
So absolutely. So what I wanted to start with is this, and you mentioned it, you have some very legacy automation systems in your buildings where you're only getting a temperature, and it's funny. But it's this when do you start dilemma. I call it the chicken or egg, because when I talk to universities, we don't really have not upgraded all of our systems and infrastructure to really start collecting data, so we want to wait. But I come from a place where you can take what you have and start analyzing it. To your chiller example there, it may provide you insight in how you should upgrade your automation. And what would be your advice to another university of when do you actually start this process?
It goes back to the comment I made with the energy meters. You've got to look at what's capable and start with the low-hanging fruit. You get useful information out of whatever it is that you can collect. And often you may be able to get more than you think if you scratch your head about how you connect it to systems. So an example is, we have the iNet product, we have the Xenter product, and we have the Structureware Automation Server product. You can now actually put all of those iNet controllers into the Structureware 3 software product and have them seamlessly controlled from inside that software product. Before that occurred, there was a software link in the background that you could actually take advantage of and do, if you like, we did what we determined a kludge, in that we used the software on the head-end server from iNet and then managed to push that into a standard Structureware trend log. So we could actually get some very simple data, not a lot, but we pick a key, key temperatures, key things off that very old iNet controller and get it into a structure-aware trend log. And we didn't have the interface at that point, but we did have the reporting server from Schneider, which was a SQL database. So we did a little bit of back-end figuring, and came up with a stored query that would extract the trend log data out of the Schneider trend logs, and we could then run an RDBMS Pi interface, run the stored query on the reporting server, and pull back the data from that trend log and feed it into a trend in Pi. So you had this, this connection of tin cans and string delivering a Pi value. And again, it was only a 15-minute temperature log, but a 15-minute temperature log in a key lecture theatre over time can tell you a lot of things. So if you scratch your head and think about your comms pathways and what is actually possible with the collection you've got, you can actually, depending on how old your stuff is. I mean, we've got some Honeywell that's pure analog. There is no connection to it whatsoever. You've got no hope. But if it's got comms and it comes back to a head end, there may be an intermediary path that you could actually get something useful. So again, we had iNet data coming back for 2 or 3 years via a software link and an RDBMS call from a reporting server. So there are ways, if you think creatively, to get data back. But again, starting is actually the hard bit, and actually going, again, we're starting with a lot of our looking at chillers, because chillers are high energy. So think about what are your big items? Where can you get the most impact? And then look at those first. For chillers, for example, your key measure is going to be energy and your return and leaving temps. And again, it's not that difficult to get out there and potentially even just put a surface mount temp sensor on the pipe. You're going to be a half degree off, but your diff's going to be within a half a degree, and that's going to tell you a lot of information directly. And it's not difficult to get that sort of reporting information back. We've got some hot and cold water temperature sensors for some of our domestic reticulation. It's coming into a Moxa 1200 series thermocouple unit with some pipe clamps and RTDs. It gives you a good enough number to be able to actually make sensible decisions. Is the water at 70 degrees or 60 degrees? Are we wasting energy heating it? Plus minus 2 degrees on that is better than you need.
No, absolutely. And I looked at some of your examples where you save some money, like the water. It's not complex. It's just simply start and you'll be able to find value.
Yeah.
But that raises an interesting question. So I'm presenting to some national labs next week, and I was looking at some cybersecurity around universities.
Yes.
And unfortunately, there's been some incidents. A couple universities have paid ransomware in North America. Europe, there's been some incidents. Now, most stay on the IT side, but to me, the operational side, which a lot of these control systems and some of the legacy systems you run lack strong cybersecurity. How did you guys approach cybersecurity as you kind of expose this data?
This data is flowing back generally through now Windows Server 2019 boxes with Active Directory login. The new Schneider product supports Active Directory. But from a building configuration perspective, all of our legacy devices are sitting on private networks. They're only accessible from we've recently stood up a specific data center subnet, which has specific ACLs, so access control list protection, only to the building control networks that are all on their own private networks. So we've inside the corporate VLAN structure carved out specific VLANs in each building that have very, very specific access rules that our cameras and building management solutions and most of the other low-level, not particularly smart devices sit on. So it's very much defense in depth, and it's ring fencing from a thinking about your network partition VLANs and who is actually allowed to connect to the head-end servers. So it's again defense in depth, thinking very carefully about where it's visible. PyVision is read-only to all the university. The web API to that comes out is read-only back to the main servers. All of my interfaces that I've stood up to bring data back from the field, they're all the read-only instances of that. So we've got DMP3 coming back from the field for our water, because we've got a 400 mech radio comms network that goes out into the middle of the forest that's powered by solar and batteries off streetlight circuits and all sorts of strange things. But again, that is all coming back into a base station that's sitting on a private 10 network that is ring-fenced and only accessible by the interface server software instance, which is read-only.
Oh, absolutely. That sounds good. I think one of the things that I hear the most in what you said is, besides all the technical architecture, which you definitely hit on, is the separation of data from control.
Yes.
Which is really a foundational thing that you've designed here. And by separating that, it's because cybersecurity is not only an external threat. Sometimes cybersecurity is our own protections from the lack of training or the lack of focus on that specific control. So I'm very excited to hear what you've done there. So thank you.
Yeah, no, it's very much a focus. I treat, from an industrial perspective, I treat the building management solution effectively as a SCADA. And the control resides with the building management. The OSIsoft product is acting as a pure analytics historizing solution, and it is read-only from the control architecture. So again, it allows us to get a nice handover between vendors as well. You own this is yours, you own the control. We don't touch the control. So it gives you a nice simple handover point as well.
Good, thank you.
Great. I think you mentioned before that you're using AF and you're using templates in AF because you got hundreds and hundreds of
Yes.
similar things. Can you describe what the value's been that to you, or how do the templates help you do all this?
Well, we have about 4 different meter manufacturers. So I've basically got a template per meter, and then I can instantiate that, change a few of the configuration point attributes in each tag, and point it at the right Modbus gateway. Makes it very, very simple. So you've got all of your mins, maxes, scans, all of the others are all set up. You literally put in the right IP address, put in the right unit ID for the Modbus connection, and it lights up. And then you do your end-to-end checks. You get your Sparky in the field, put a clamp meter on the copper, and he says, okay, that's 40 amps. And then you look at the pi tag and go, I'm getting 40 amps. I'm happy.
Okay.
So
and
templates,
all those displays. I'm
Yep.
sorry. Go ahead.
I say templates allow you to spool up meters very quickly.
Right. And the displays you were showing, I'm guessing almost all of those were driven by templates.
All of those are driven by templates, and a lot of them are driven as well by categorization of the templates in the structure. So we saw the display that had a building meter and sub-meters. We've got additional displays, and those sub-meters are actually broken further down by electrical, mechanical, lights. So you can quite easily, inside a PyVision display, choose from a collection search perspective exactly which meters you wish to target out of the whole tree.
Okay. Now, and do I understand it correctly that you're using notifications, but right now you're just limiting who sees that? You're basically having this stuff directed specifically, not to a real wide audience. Did I get that right?
Yes. So I get notifications when one of my meters stops working.
Okay. And if you don't mind me interrupting right there, the point I had about that is, and you're doing that because of the danger of giving people over notification. Can you explain that? That's a fascinating topic that we hear about all the time when you do our training.
Yeah, I come out of, as I said, an interesting industrial and defense background. So I'm very, very aware of the inability of humans to process many things fast. So that the term, I believe, is alarm flood. So you do not wish to be giving people noise. So I've been very, very careful to separate out only things that people need to see or need to act on. So we've been doing this across both the building management system as well as Pi. So we very, very carefully consume our own notifications internally first and check they're not noisy. check they're doing exactly what we want before we actually push them to anybody else. And again, it's one of those very fine things that I'm looking at, how do we do this in conjunction with the engineering team? Because, unless somebody needs to act on it, they don't need to know about it now. It doesn't need to be a text unless you're expecting them to do something. And again, we're looking at -80 freezer monitoring with a separate system. And again, it's who is the target audience of that alert? Do they need to know about it right now? If so, then yes, it's valid to send it. If it's something that's better in an email report that tells them how their asset's performing over time, that potentially needs to be a weekly or monthly report email that just drops in and they can look at when they've got some time and they can analyze it. So again, it's and again, there's a lot of things that you can put into notifications that are useful for people like me that's doing the development of the notification or the analysis. The user doesn't need to see those. They're development notifications. They're way down the list. I've got an inbox that's organized and can handle 500 emails a day from things that are chattering away that need a good looking at. I'm quite happy to have those, but my view of the process is very, very different to somebody that needs to know, I've got a water leak, I need to start walking around the campus and looking for green water pouring down a drain. So, I need to be sure that when I'm sending the facilities manager a text or an email that says, oi, go look for a leak, that I'm confident we've got something. So, you need to be very careful. There's a fine line there between, too many notifications that people ignore or getting it right so that that some action will actually occur when it's something that needs action.
Okay, great. Brian, thank you so much for spending this time with us. This is just data dense, absolutely. It's like double Dutch chocolate, hearing all the details. And it's a tour de force, especially with the Pi Vision stuff you showed us. I really appreciate it.
Pleasure.
And I got a real quick lightning round for you. We always like to know what
Sure.
everybody else in manufacturing and industrial is doing. So in where you are in facilities, especially at university, do you guys say you wear fireproof clothing? You wear steel tip shoes?
Plant rooms need steel caps, and again,
Okay.
when we're going on site for design and construct builds, then it's up to the builder to determine what's on. So it's the usual hard hat, goggles, long sleeves, long pants, steel caps, gloves on the belt. So
Okay.
if it's being built, otherwise plant rooms, it's sensible cotton attire and steel caps.
Well, so you were obviously work with data. What's the coolest calculation or code that you've ever done?
Data. Well, actually, for the most entertaining calculation I've ever done, I'd actually have to go back to my PLC days. And I had a 24-bit encoder, and I was bringing the data into a 16-bit PLC. So I needed to take the 24 bits that were coming in, push it across two 16-bit registers, and then manually do a 2's complement calculation to put it into a floating point so I could actually use it. So that's probably the most entertaining calculation I've had to manage.
That's great. Thanks for sharing. That's very cool. So finally, if you can keep it to one or two, what's the first couple of computers you ever used in your life?
Well, if we go back to high school, my first poke around was with a Sinclair ZX81, and plugged into the TV with the old membrane keyboard. And that was followed up by my friend getting a Commodore 64 with the old cassette tape drive that we used to play a few games on and do a bit of playing about with. From a work perspective, probably the most entertaining one I worked with was back in the Navy when the first ship I served on had a Franti 13-bit computer which ran all of the display and weapons targeting systems, and the ops program for that got loaded in off my punch tape. And the memory for that was in 1K chunks on ferrite core. So, yeah, I have an interesting background in computing.
Okay, well, I really appreciate your time. Thank you so much, Brian. Scott, thank you so much for joining us and doing such insightful questions.
Thank you, Brian, and thanks, Nick. I appreciate the time.
It's been a pleasure. Thanks very much, guys.
Thank you. And thank you, everybody, for joining us. Please, come back every time. This is our conversations on critical operations. Come back next week or next couple of weeks. You'll see us on podcasts on as Radio Pi. So please feel free to join us on that. And again, thanks for joining us, and we'll see you soon. Bye-bye.